It was Monday morning. I just started moving some of our services from Node 14 to Node 16. One service down, all was good. The second went great. And then this error. This error, this error. Today I'm going to talk to you about everything I learned while trying to resolve this error. We're going to see how to read pre-dependency errors, which are like this. We're going to get a deeper explanation of what pre-dependencies are and the difference between them, between every other type of dependency. We're going to explain how node model resolution actually work, and we're going to see who is this entity that's managing all of our dependencies every day. But before that, hello. My name is Omri Bar Zik. I'm a front-end infrastructure developer at Arborist. I have Node, Docker, terminals, but I'm also a third-generation developer here in Israel. Here you can see me and my father goofing around, and here is me and my grandfather just sitting together at the kitchen table. And as a child, I remember me and my grandfather sitting together and talking about everything and nothing. I told him about my day, and he told me stories about his. But also, we were talking about computers. We were talking about how do they work, how to think like them, and sometimes we even talked about how we can solve issues and problems with them. And along the years, my grandfather told me many stories, but this one really stuck with me. It was a story about an engineer who worked at the factory. And one day, they saw a puddle of water on the floor. So they quickly grabbed them up and cleaned it up. But before they continued with their day, they stopped and asked why. Why was their puddle in the first place? Well, they looked around and found out that apparently the overhead pipe was leaking. So they grabbed a wrench and a ladder and fixed it up. But again they asked, why was the pipe leaking? They have continued to follow the line and found out that apparently the water pressure was too high. So they lowered the water pressure. But again, they stopped and asked, why was the water pressure too high? They found out that apparently the control valve was malfunctioning. So they grabbed a new one and fixed it. But again, they asked why? Why was it malfunctioning? After they talked with their peers a bit, they found out that apparently no one was checking the control valve in this part of the factory. And again, for the final time, they asked why was nobody checking the control valve there? And they found out that it was just missing from the maintenance schedule. By asking why again and again, we have found out the issue that causes all of the other problems. And by fixing it, we have successfully prevented more severe issues in the future. This way of thinking is called the 5 whys. It originated by Shitaki Toyota, the owner and the inventor of Toyota Corporation. And it is an analysis tool to help us find root causes in problems we face every day. And with this in mind, let's ask ourselves the first question. Why did we got this error in the first place? I know this error was related to the change I did from Node 14 to Node 16, and I know this error is related somehow to NPM. So let's find out what happens there. First, I did a quick Google search and found out this Medium article. I scrolled down a bit, looking for anything that resembles NPM, until I found this line. Apparently, NPM was upgraded from NPM 6 to NPM 7. This raises our second question. Why NPM 7 yells at us? To understand that, let's come back to the error from before and try to read it. At first, this error looks impossible to understand. Don't even try to read it like this. So let's remove some of the unnecessary text. Good. Now we can take a deep breath and start reading it line by line. First, this error is divided into 2 parts, the current state and the problem. Good. In the current state, NPM tells us they have found ESLint version 7 installed. And 2 lines under that, it tells us from where he got it. We can see that ESLint is a dev dependency that originated from our root package, for our root project, aka our package log, package.json. Now, in the problem area, and here you can see that there you can see where it is and where we expected it to be. In the problem area, NPM tells us that ESLint is a peer dependency to some other package. And this peer dependency has an exact requirements that ESLint cannot be smaller than 1.6 and no larger than 7. Next to this arrow, we can see where this peer dependency originated from. And in this case, it's a Vue CLI plugin for ESLint. And like before, 2 lines under that, we can see that this Vue CLI plugin is a dev dependency from our package.json. And if we open our package.json, here it is, right where we expected it, blue and black. Now to understand those two parts, let's look at the whole error again. First, NPM tells us they have found ESLint version 7 installed. But then, NPM tells us that some other package need ESLint to be less than version 7. This is our conflict. But let's put this conflict aside and ask ourselves the third question. Why peer dependencies are the problem? In NPM, we have 3 types of dependencies. We have prod dependencies, or normal dependencies. We have dev dependencies, and we have peer dependencies. Prod dependencies are every dependency that we need while our package run at runtime. That means packages like Axios, Lodash, or Node.js. And because of that, NPM ensures that these packages will be installed when someone installs our package at the requested versions we specified, no matter what. And then we have the dev dependencies. The dev dependencies are every dependency that our package needs while developing our package. Packages like our linters, our testing libraries, our bundlers. And because we only need those packages when we are developing, NPM does not install them at all when someone installs our package. Peer dependencies are a bit different because peer dependencies are like prod dependencies, meaning NPM will install them automatically when someone installs our package, but it will install alongside our package. We usually need this kind of behavior when we are building plugins. Let's say you want to create a ESLint plugin, or maybe a Webpack loader, or even a React component library. Let's say I have this package called ChuckJokes. ChuckJokes is a React library that's a render a random Chuck Norris jokes, but with typos. A must for every application. And ChuckJokes have a React peer dependency. When I'm installing ChuckJokes into my project, it will look like this at the start. But when I will run npm install, the internal brain of npm will look at this like this. And those two package.jsons are exactly the same. And this is mainly the change that happens between npm 6 to npm 7. In npm 6, you needed to install them manually, like on the left. But in npm 7, they are installed automatically. Let's see where this can be the problem. Let's say before I installed ChuckJokes, I've already had React 17 installed in my package. By running ChuckJokes, I've installed both React 17 and React 18 at the same time. This is our conflict. And this is the sole reason why we have peer dependency conflicts inside our repo. Now, let's put this conflict aside and ask ourselves the fourth question. Why prod dependencies are not the problem? And in prod dependencies, let's say I have this setup where my project have both ChuckJokes and Axios 0, and ChuckJokes have only Axios 0. When I will run npm install into my project, I will see this node module structure where ChuckJokes and Axios are on the same level. Now, in this scenario, where I have different packages, where ChuckJokes only have Axios version 0, and my project have both Axios and the ChuckJokes, but with Axios on version 1. When I run npm install onto my project, I will see this node module structure. This is because we said before that npm ensures that every dependency will get its required version no matter what. And because of that, npm will create multiple node modules directories for each package. Please note that ChuckJokes have the Axios version 0 closer to it, and my project have Axios version 1 closer to it. Now, This is our fifth and final question. Why do we care where we put our dependencies? Well, let me reduce to you those two concepts, the dependency graph and the dependency tree. The dependency graph is a complex web of circular dependencies, colliding versions, but it gives us a full diagram of how every dependency is connected to one another. The dependency graph and the dependency tree is a data structure that enables us to model how npm, how the node module directory will actually be inside our file system. And the one important mission of npm is converting from this dependency graph to this dependency tree. And I think the best way to show you the scale and the amount of processing power npm needs to actually convert from this to that is by showing you this demo. This is a single node that represents ESLint. And around this, there's millions of different nodes. But let's look a little bit back and see the sheer scale of how every single npm dependency lives inside our ecosystem. This whole galaxy is representing how every different npm package is connected to every other npm package. And think about the scale and the amount of calculation you need to do from converting this to a simple tree. It's amazing. Now, when we're converting from the dependency graph to the dependency tree, there is one crucial thing that npm does while doing so. It thinks about how Node resolve external modules. So let's see what it actually does. Every time, right? Cool. By the way, if you want to open and see this galaxy inside your phone right now, this is how you can scan this QR code. And it's actually amazing because you can navigate with your phone and see it with different space. It's really cool. Wait there. If you want this QR code, I promise I will give you after the show as well. Now, let's say I have this source.js file. And this source.js file has imported Express. When Node executes this file, it would start searching for this Express library for first in this SRC folder, and then in its parent, until it gets to the root. I think, and let me show you how it actually does it. First, Node.js will start looking again in the SRC folder for any node module that exists. If it doesn't find it, it will go to the Omri folder. If it's not, to the user folder. And if not, it go to the file root. And if it doesn't find it in the file root, it will throw us an error. Now, this tells us two things. First, every module that we have installed in this node module directory on our file root of our file system can be accessible to any other JavaScript file inside our system. Second, this enables us to control different versions to different JavaScript executables. Because when Node finds a node module, it will stop there and will not continue up. Let's say this in action. Let's say I have this setup, where I have an src lib, and inside this src lib, I have this lib.js directory and this bar.js. Under this lib directory, I have this foo.js file. And both foo.js and bar.js have as imported Express to them. Now, when I first execute bar.js, Node will go to the src folder, then try to search for any node module directories inside it. And if it finds a node module directory, it will try to find a package, a directory with the same name of our package. And in this case, it was successful. Neat. Next, let's run bar.js, foo.js. Foo.js, again, Node will go to the parent directory, in this case, lib, open the node module directory, if it exists, of course, and again, it tried to find this Express folder. And again, it was successful. Please note that even though we had an Express folder inside the src lib, and lib is inside src, a node does not go up there because he found this node models with express first. Now, let me introduce to you to this entity that is responsible for all of this managing from our peer dependencies, dev dependencies, and converting this tree to a graph. Arborist module, the tree sergeant of NPM. And Arborist is a really special module inside NPM because it not only manages dependencies, it manages if the packages are authenticated or auth. It manages workspaces, but again, it manages dependencies as well. And today we're going to focus specifically on how Arborist manages dependencies. First, every time you run npm install, Arborist will run in general, these 4 steps. First, it will analyze your project. It will try to read your node module directory, your package.json, your package log, and even your yarn log if you have some. After it analyzes your repo, it will create a so-called actual tree. This tree is a model that represents how the modules are live inside your file system. After it analyzes your repo, it starts building something called an ideal tree. And this building stage is the complicated part of Arborist because it takes this huge dependency tree that we saw before and start to convert it to this huge dependency graph to this dependency tree. And this is the most complicated part and takes the most time to execute because it needs to fetch not only your packages that inside your current project, which can be sometimes dozens of different packages. It needs to fetch these packages and calculate how different versions need to be supplied in this huge tree that we are building. After it finished building this ideal tree, it starts planning of how to convert from this ideal tree to this actual tree. So it sees what package do I need to add here, what package do I need to remove, what package do I need to update, and it tries to do it while taking the smallest amount of steps as possible. After it plans this step, it starts to execute it. And this executing is a really nice part about Arborist because it's fully rollbackable. Because in this step, Arborist starts to remove node modules. It starts to add packages. It starts to update them. And you need to manage to work on this on every file system, meaning on Linux, on Windows, on Mac. And no matter when in this process you press Control-C or stop this process by killing or something like that, Arborist can know how to roll back your tree to this original state. Did you ever think about that if you are now installing some package and then you said, no, I didn't mean to install them, and press Control-C multiple times, you can still use your application exactly the same. This is because when Arborist executes its plan, it takes note on each node it moved and where they were, and can do a full rollback when they want to. Now, with this in mind, by learning this deep understanding of how NPM works and how Node resolve modules and how this actually error exists, let's try to understand and solve this error. And the solution is really simple. All you need to downgrade ESLint, or you need to upgrade the VueCLI plugin to some version that can accept ESLint 7. And I know for some of you, this solution is seen obvious from the start. But now, when you know and understand this deep level of why this solution starts, you can now really solve those issues without going to some Stack Overflow or ChatGPT and just copy and paste the answer. By really understanding, you can just go and discover this issue yourself and solve it by yourself. And by doing it, you could even prevent it from future developers that will encounter this error. And they will encounter this error. Let's just sum up everything we have talked about. We have talked about how peer dependencies actually work. We have seen what do they mean, how to read this error, and what is the main difference between peer dependency, pro dependencies, and dev dependencies. We have seen how node module resolution actually calculate where is this module lives inside our file system, and how it tries to understand what module do you want to import and what priorities it takes. And at the end, we have seen how this Arborist module is actually managing all of our dependencies every day. And this is the sole reason that we can install, update, and remove millions of dependencies and packages around the world every day. This talk was brief and short in some parts, but this is a QR code that goes to multiple Medium articles that I wrote while trying to understand this lecture and trying to give you the best way of explaining everything that I did here. And I hope you had a great time, and I hope you had a great day. Thank you very much.